Hello, welcome to episode 10 of Getting Started with Attributes and VOPs inside of Houdini. And in this one, we'll be learning how to create this holographic type of effect. And actually, we will not be just focusing on creating this effect. We will be talking about how to use attributes in other applications and DCCs that we can use, that we can export from Houdini and use inside of, for example, Unreal Engine 5. And I'll show you how we can write down the color attributes into the points, copy them, and then use that in material system of Unreal Engine to create this kind of interesting holographic effect, as you can see here. All the while, we'll actually be learning a couple of other things and using nodes we already know and new nodes that we don't know yet. So let's get started. And as per usual, we start with Geo. So I start typing the Geo, enter, and first things first, let's create a grid, because, well, that's where we will be scattering our points and making things appear. And next, we will do the, well, scatter, of course. Now, the interesting part is that between the grid and scatter, and as you know from previous videos, when we will be scattering our points, they will inherit the attributes that come from the upstream of our nodal network. So what does it mean? It means that if we do some kind of for example, colorization, the scattering point will inherit this colorization. So there is this node, which is called attribute from map, and we just can type map from, here it is, attribute from map, and it says CD. So basically it gets us the color diffuse. And before we do anything else, I just want to say that let's increase the rows and columns to 250 by 250 so we have enough resolution. And of course, next thing you should do is, find some sort of picture you want. And in my case, I'm just going to use the picture I used, result from Stable Diffusion. I was using for my avatar on Twitter for a couple of months. I don't anymore. So anyway, you can use any picture you want, right? So just don't forget to give it enough resolution. Otherwise, it will be blurry and not look really good. So what we're going to do now is we go to image settings and we can invert the U, we can invert the V, and I think this is the correct way it should be looking. And of course, if we scatter now and let's say I increase the number of points to something like 70,000, you'll see that indeed we have our result. However, this is not how I want our points to be distributed. As you can see, we have the relaxed iterations. Obviously, it tries its best to organize points in some sort of grid. However, there is a node that's called points from volume, and you will immediately see that in fact this creates a perfect grid, right? So here it is. If I make point separation a little bit more, you will see it a little bit better. If I make it slightly less, well, basically you know what to expect. However, the interesting part here is that we can switch from grid to tetrahedral, and you will see it goes into these ways of rows which are even and odd. As you can see, this row is offset to another row by kind of like 50% of the distance between the points. So interestingly enough, you will see that it's called points from volume. However, we don't have volume just yet, as you can see, right? However, it can interpret the surface as a volume and scatter points nonetheless. But this is not what I want. I want to do the extrusion, and I want to extrude them up and down at the same time. And in fact, there is this thing that's called lapse thicken, which does exactly that. You will see in a second what I mean. So as you can see, it just thickens the thing, right? However, if we press both directions, you will see, well, it does what it says. It makes actual surface thick. So I connect that to our points from volume, and you will see that indeed we start having the kind of like result that we need. And let me drop just the null, because this blue preview gets a little bit annoying to look at. And I think it will be just fine if we have like 5, maybe 6 rows. Let's see if we can tweak it. I think we already have 5 rows. Let's see, something like, okay, 3. All right, 0.06. I think this will do just fine. So why are we doing it like this? Is because if we feed the attribute from map to the points from volume, we'll see that it actually doesn't inherit because it goes through the volume, and volume doesn't inherit the color. And the point is that actually there is another effect I wanted, is that I want the projection to be kind of like be saturated in the middle and a little bit blurred out on the top layer and on the bottom layer. So what I'm trying to say is we have these points and we will actually transfer attributes from this scatter to these points. This is why we have so many points, so that we have something to work with. Anyway, so we do attribute transfer, and we have attribute transfer to and attribute transfer from. And as you will see, we already have some sort of result, and it's kind of pretty good. However, if you know, and if you watched the video previously, we know that there is this distance threshold, which kind of controls how much distance is being taken into account. As you can see, the top points, they do not really inherit the color, right? They're kind of white, but the middle colors, they work just fine. So we can increase the blend width to fix that. However, I want this color to drive the emission color from our materials in Unreal Engine. So I want the initial color of our points not to be white. I want them to be, well, black, because otherwise they will emit on their own, and that's not what I want. So this is what we get if we decrease the blend width, right? You will see that indeed some points are getting very black, which means that the distance threshold works kind of like almost as expected, right? Kind of like somewhere around there, and we increase ever so slightly the blend. Now, how do we utilize this? First of all, let's check how many points we have. It's about 160,000. I think it will do fine, hopefully. So what we need to do next is actually create some spheres. And before we do anything with our spheres, let's check out which one we're going to use. And it will be just polygon, and it will be frequency of 1. And trust me, this will be enough because they will be so small we will not see it. Now, the normals look kind of wacky. So what we do is drop the normal, go to the face area, make 180. So from the distance, it will look like a perfect sphere. And well, basically, that's what we need. So we do the copy to points, press enter. This is geometry to copy, yes. And this is points to copy to. And of course, our spheres are too large. Let's see, 0.1, too large still, 0.01. Now they're too small, something in between, maybe 0.3. Yep, that works pretty well. So this is nice. And finally, as you can see, our spheres, initially, they are only built from triangles. And this is what you need to be working properly inside of Unreal Engine. But if you, for example, wanted to do some sort of platonic solids, dodecahedron, right? First, you would need to actually divide it to make it triangles. Otherwise, Unreal Engine would be confused what to do with your geometry. But again, since we already have only triangles that are constructing our sphere, this will work just fine. Anyway, there is that. The only thing important to us right now is that we have proper colors and proper normals. Next thing, we will actually write down the alembic, and it's called alembic wrap output. So previously I was using FBX, but this is static geometry. Alembic is a file format that is used to cache geometry, to create static geometry, animated geometry for VFX or what have you. But in our case, we're just writing down one frame from this geometry, and Alembic, as FBX, it does retain all the attributes. So unlike OBJ that does not have animations or the attributes built in. So what I'm trying to say is usually we use FBX. You can just now know that we can also use Alembics and it will work just fine. So we'll call it projection 01, ABC, save to disk, and it should work just fine. Next thing we should do is we go to our Unreal Engine. I will delete this. And as you can see, I have wall of points, and let's actually create a new one. Let's call it projection tests. Go inside, and of course we need to import. And our home folder, as you know from here, right? We wrote $home, it means it's in our documents. So I just double click, unclick generate map UVs. We don't need that. Everything is kind of like whatever. We can just press import. So it has 3 million polygons. It might take a couple of seconds to import. If I'm not mistaken, the actual geometry import is single threaded. We can actually see if I'm right. And as you can see, Unreal Editor uses from 8 to 15% of my CPU, which means basically it really is single threaded. So anyway, let's have our sun back and let's drop the projection here. And of course it is too small, so I increased the scale to 25 or something. Let me just enable the real time so it kind of works much better. And that's what we get. So you might look at this and think, wait a minute, where's our colors, right? So, so the colors actually come from the material, and we can create projection, master material, like something like that. It doesn't really matter. So double click here, and we can go to vertex color, and the vertex color, connect to base color. Let's see what we get. Oh, yes. And of course, I forgot to actually assign this material to this geometry. And finally, we have our result, and it's upside down. All right, much better. And like this. Okay, finally, we have some sort of result that we actually needed, what we actually want. Now, the next part, I'll just press Ctrl-Shift-S to save everything. I'll right-click and enable nanite. And it says preparing static meshes. It will take another couple of seconds. And when I say a couple of seconds, I actually don't know how much time it will take, but hopefully not too long. And the interesting part here is that the nanite conversion also actually uses just one CPU core. This is why it's not really fast. And by the way, the nanite conversion takes a lot of memory. So if you have like 10 million polygons or something, this might take 15 gigabytes of memory or sometimes even more. What I'm trying to say is if you're working with really huge geometries, it will take a lot of time to convert to nanite, and it will take a lot of memory as well. Anyway, so here's our geometry. And if you remember, I was saying that I want to drive the actual emission using our colors. So this is exactly what we're going to do. I'm going to connect this to emissive color, but before that, I want to create emission multiplier strength, something like this. Let's call it 0.1. The multiplier here will be actually the color that goes from our vertex color. And now that I can save, and of course, now we have the control of the emission of our geometry. And naturally, if I get rid of our sun, you will see it's our projection. Whoops, let me increase the screen percentage to make it a little bit better. Our effect works as expected, and everything is, well, sort of perfect. And there you go. This is how we can use the attributes from Houdini in any other application of our choice. So the whole point I'm trying to say here is that you can basically create anything, any attribute that you want, and you can use them in any other application. It doesn't have to be Unreal Engine. It can be Blender or Maya or Cinema or whichever. And of course, here we were using the color of our points, but in the same vein, you can use like velocity or something else, or density. We'll talk about volumetric attributes when we'll be exporting like clouds and stuff like that from Houdini into rendering with Blender's Eevee and cycles. But that's for another video. In this one, I just wanted to show you that you can indeed use. Now, the final thing I want to say that you will see that we actually made the class of our colors points, right? What I'm trying to say is the color, as you can see, CD, are on points. However, in the Unreal Engine editor, you will see that we are getting the vertex colors to drive our emission, so to speak. It doesn't really matter because when we have any sort of color information on our geometry, the vertex colors and the point colors and whichever, they just use the same color. So In this case, we could be really pedantic and attribute promote, for example, the points like this. We get CD from points to vertex, but in this case this is redundant. This is why I didn't do it. So we can just use the point colors because they're the same that we use on vertex colors. Hopefully this is not, super confusing. Anyway, here we are. This is our pretty cool looking holographic projection thing. So there is that. Hopefully you learned something useful, and if you like the videos, if you have some ideas, suggestions, don't hesitate to leave a comment. And if you're interested in learning more about Houdini, Unreal Engine, maybe Blender, well, basically CG in general, don't forget to subscribe to the channel, and I hope to see you in the next videos. Have a nice day. Bye bye.